Okay. Good evening, Kirti. It is a multiple if class switch. Okay. Here we have switch and case. We completed this, and after that we started iterative structures. What are the iterative structures we have? Do while, and for loop. Hmm. जाओ उधर, जाओ उधर, जाओ. Hey. Okay. While, do while, and for loop. What is do while? It will check the condition. But before checking the condition, it executes the statement at least one time. After then only it will check the condition. Okay. For example, on our previous class, we print 10 numbers. Okay. After that, while class. What is the while? First, it will check the condition. If the condition is true, then only it will execute the statements or code. Okay. Our today's class is okay. Our today's class is find the Armstrong number. Find the Armstrong number. Write a program to check whether given number is Armstrong number or not. Okay, Armstrong number or not. I want to check whether the given number, we will give the number at runtime. Okay, those numbers are Armstrong number or not. What is the Armstrong number? Anyone? What are the Armstrong numbers we have? Okay, some Armstrong numbers. 153, 153, which is nothing but 1 power 3 plus 5 power 3 plus 3 power 3, nothing but cube. Very good. Sum of the cubes of individual numbers are nothing but same number. Here, you see, okay, 153. Okay, 1 power 3, nothing but 1 plus 5 power 3. 5 power 3, 5 into 5 into 5, which is nothing but 125. 3 power 3, which is nothing but 27. 3 3 the 9, 9 3 the 27. Okay. Okay. One plus 125 plus, okay, 27, which is nothing but 153. One more number, Armstrong number 371. 371. 371. Okay, which is nothing but 3 power 3 plus 7 power 3 plus 1 power 3. 3 power 3, which is nothing but 27 plus 7 power 3. 7 7 the 49, 49 7 the 343, I think, right? Plus 1 power 3, which is nothing but 1. If you add 27 plus 343 plus 1, then it is nothing but 371. Okay, so that is called Armstrong number. Okay, tell me. So this is about Armstrong number. I want to find out whether the given number is Armstrong number or not. Okay, program. Okay, first we have to include stdio.h. If you want to include, no problem. It is optional. Console io.h. Next, use void main. Here I need, okay, one variable which is nothing but the given number which I have entered at the time of runtime. Okay, and I want to store the initial value of n in some n1 because I need to compare. Next time I need reminder and I want to add some zeros. I will explain what are these use of these variables n, n1, remainder and number. You can use as ABCD also, no problem. Okay, clear screen. Okay, printf enter a number. Enter a number and scanf is used to store that number or scan that number. Which number? That number stored in n. That number stored in n. Okay, I have to enter one number to check whether the given number is Armstrong number or not. That number stored in n, address of n. Okay, now initially what we have to do, we have to store the initial n value into n1. Why? Because we have to compare. Okay, so n1 is equal to n. It means the value of n stored in n1. Okay, na? Next I will to check the condition. I want to check the condition. Okay, n is not equal to 0 until n is not equal to 0. I want to repeat the code. Until n is not equal to 0, I want to repeat the code. Okay, first I need reminder. How can we get the reminder? By using
n
percentile 10. Okay, whenever you divide with percentile or mod, it will give the reminder. Okay, now again, now number is equal to number plus reminder into reminder into reminder. Okay, now n is equal to n by 10. it will give the coefficient. It will give the coefficient. Why? Because I declared n as a integer. Because I declared n as a integer. So it will give the coefficient. N is equal to n by 10. And close the bracket. If number, okay, if it is equal to n1, what is n1 here? Initial value of n. What is n1 here? Initial value of n. If both are equal, then we can say given number is Armstrong number. Given number is Armstrong number. Okay, close the brackets. Else, printf given number is not a okay, else and close this. This is about program. Here, what is the logic we have? This one. It is a logic. Okay, I will explain the logic. Here it says enter a number. For example, I entered one number which is nothing but 153, right? Next, n1 is equal to n. So what is the n1 value now? 153. Why? Because n1 is nothing but n. What is the initial n value? 153. So now initial n value stored in n1. Now it will check the condition. Okay. While n not equal to 0. What is the n value? 153. It means 153 is not equal to 0. It is true, right? 153 is not equal to 0. It is true. Who is that, beta? Chandrasekhar. Okay. Nitishri, good evening. Pallavi, good evening. Okay. Next remainder is equal to. Next remainder is equal to n modulo 10. N modulo 10. Okay, na? N modulo 10, which is nothing but 153 modulo 10. It means 153 divided by 10. So the remainder is 3. Because 10 1 the 10, 5, 53, 10 5 the 53. So remainder is 3. Always, whenever you divide by 10, the remainder is the last digit. What is the last digit? 3. Okay, na? So remainder is 3 now. Remainder is 3. Now here you see num is equal to num. Okay. Num is equal to num. It is the initial num value, previous num value. What is the previous num value? 0. So it is nothing but 0 plus, you see, num plus 0 plus remainder into remainder into remainder, which is nothing but 3. So it is nothing but 3 into 3 into 3. Okay. 0 plus 3 3 the 9, 9 3 the 27, 9 3 the 27. So 0 plus 27, how much? 27. Okay, so what is the num value now? 27. What is the previous num value? 0. What is the previous? 0. Okay. So here num is equal to 27. Okay. So num is equal to 27. Previously it is 0. Now it is 27. Next, third line, n is equal to n by 10. N is equal to n by 10. N is equal to n by 10. 153 by 10. What is the n value? 153, right? 153 by 10. Whenever you divide by 10, the quotient is the remaining digits, which is nothing but 15. Okay, when you divide any number by 10, okay, forget the last digit and it will give the remaining digits, which is nothing but 15. So now what is the n value? 15. What is the n value? 15. Now you see what is the n value? 15. You got it? Very good. Now you see everything is clear. Now what is n value? 15 and number is 27. Previously number is 0 and n value is 153, right? N value is 153. Now n value is 15. Again it will check the condition. What is the condition? While n not equal to 0. What is n? 15. 15 is not equal to 0. Tell me this condition is true or false? It is a true. Why? Because 15 is not equal to 0. 15 is not equal to 0. Okay. Now again we have to execute this statement. Okay. 15 is not equal to 0. Condition is true. So again it will check. Remainder is equal to remainder is equal to n modulo 10. Nothing but 15. 15 modulo 10. If you divide 15 by 10, what is the remainder? The last digit, so which is nothing but 5. So what is the remainder now? 5. Okay. Now it executes the second statement or next statement. Num is equal to num plus. So is it 0 or 27? It is 27. Why? Because initially num value is 0. Now what is the num value? 27. Okay. Next plus remainder. Okay. So here what is the remainder? Which is nothing but 5. It is nothing but 5 into 5 into 5. Okay. 27 plus 5 into 5 into 5. Very good, beta. Ritishwari. 5 into 5. 25. 25 into 5. Which is nothing but 125. 27 plus 125. How much? 152. 152. 7 plus 5, 12. 2 plus 2, 4. 152. Very good, beta. Kirti, very good, beta. 152. Okay. Now it will execute the third statement. What is the third statement? N is equal to n by 10. N is equal to n by 10. N is 15 or 153? It is 15. It is nothing but 15 divided by 10. When you divide 15 by 10, what is the coefficient? Which is nothing but 1. Why? Because 10 1 are 10. Okay, so now what is the n value? 1. What is the n value? 1. What is the number value now? 152. 152. You got it? Num value is 152 and n value is 1. You see? So, where is this one? Where is this one? Where is this one? Where is this one? Where is this? So now n is equal to 1, number is equal to 152. Initially, number is equal to 0 and n is nothing but 153. Okay? That is the thing. N1 is same. It is 153 only. Okay? Okay. While n1 not equal to 0. It is true? Yes. 1 is not equal to 0. So it will execute this statement. Remainder is equal to 1 modulo 10. 1 modulo 10. When you divide any single digit by 10, then the remainder is itself only. When you divide any single digit with 10, then the remainder is the same number. So remainder is 1. Now it is num is equal to num plus remainder plus like that. It is like that. Num is equal to num, the previous num. It is nothing but 152. 152 plus remainder into remainder into remainder into remainder. 1 into 1 into 1. 152 plus 1 into 1 into 1 into 1. How much? 1. Which is nothing but 153. So what is the num value now? 153. Okay. Next, n is equal to n by 10. N is equal to n by 10. What is the n value here? 1. 1 divided by 10. When you divide any single digit by 10, then the coefficient is 0. Then the coefficient is 0. Why? Because we declared n as an integer, not float. Okay. So here n is equal to 0. If you declare it is a float, then the n value is 0.1. Right? But I declare n values as a integer. Okay. So now what is the n value? N value 0. What is num value? 153. Okay. Now close this. Close this. Close this. Close this. Okay. Now n value is 0. It will check the condition. While n 0 not equal to 0. This condition true or false? This condition is false. Why? Because 0 is equal to 0. Okay. When the condition is false, it come out from that loop and it will execute if num is equal to n1. If num, what is the num value? 153 is equal to. We have to write 2 times. Why? Because we have to compare the left side value with right side value. If you want to assign, then use only one single. Okay. N1. What is the initial n value? N1 153. These both are true or false? It is true. 153 is equal to 153. It means it will execute this printf. If the condition is false, then it will print this one. Given number is not Armstrong number. So given number is Armstrong number. Okay. This is about Armstrong number. Got it? Our next question is అర్థమైందా అమ్మా అందరికి? Any doubt? Anjali, Chamu, Chandra, Shekhar, Kirti, Pallavi, Ritishri and Kartiki Bhale. Okay. No doubt, huh? Very good. Okay, beta. Actually, Chamu should have some doubts. Every time she asks the good questions. Okay. Well done, beta. Well done. Keep it up, Chamu. Okay. Now, we want to write on one more program. Write a program to find out sum of the digits of a given number. Write a program to find out sum of digits of a given number. For example, 345. So what will be my output? 3 plus 4 plus 5. 3 plus 4 plus 5. What is the answer? 3 plus 4 plus 5. 3 plus 4, 7. 7 plus 5, 12. So my answer should be 12. Okay, we have to write on like that program. Okay. Okay, what is our first step? We have to include stdio.h dash include console input output.h. Next, void main. Void main. Here we have to write down the local declaration. I need one variable. Okay. And I need, okay, reminder. I need reminder. And it will close within 10 minutes. Then again we have to join, reconnect beta. I tried that to purchase that one. Yes, చెప్పండి beta ఏం కావాలి? Yes, Chamu. Do you want something? Reminder. Okay. Something, which one is N1 something? Okay. Something, take different number. Okay. B. Okay. And anything else? I need one number N. Okay. Printf enter one number, scanf percentage d. That number should be stored in n. Okay. Okay. What is the logic? Initially, okay. Here we need one s also. Sum. Initial value of s is equal to 0. Okay. While n n is equal to greater than 0, or you can say n not equal to 0. Both are same here. Okay. Both satisfy the same criteria, same condition. Okay. First we need remainder. How can we get remainder? By using dividing by 10. Okay. Next. Both are बुखार है बोलता है बहुत बुखार है భయపడ్డాడు భయపడ్డా okay, this is the logic. I think no need of b also, isn't it? Only we need n value, remainder, and s is equal to 0. That's it. Okay. After that, printf sum of the digits is equal to percentage d. This percentage d is identified by or denoted by s. Okay, next close. Okay, we will see 345. So here initially s is equal to 0. SR we can call it as a sum. No problem. Okay. You can call it as a sum or s, no problem. Okay. Now n 345. What is the n value? 345. Next. While 345 greater than 0. This condition is true. S. 300 and greater than 345 greater than 0. This condition is true. Okay. It means it will execute the code. What is the code? We have 3 lines. Remainder is equal to n modulo 10. What is n beta here? Initially 345. 345 modulo 10. Okay. Just now I told you, whenever you divide any number by 10, what will be the remainder? The last digit. The last digit. So it is nothing but 5. Very good, beta. It is 5. Okay. Now s is equal to s. This s and this s both are different. Okay. It is a starting initial s. It is the last s or after the multiplication. Initial s or previous s. What is the value? 0. So it is nothing but 0 plus remainder. What is the remainder here? 5. What is the remainder? 5. 0 plus 5, 5. 0 plus 5, 5. So what is the S value now? 5. What is the S value now? 5. Okay, next. Okay, like this. Now the third one is n is equal to n by 10. N is equal to n by 10. So n is equal to, what is the n value? 345. 345 divided by 10. When you divide 345, then what will be the quotient? Okay, very good, beta. Okay, except last digit, which is nothing but 34. Why? Because I declared another integer, so it should give 34 only, not 34.5. It is 34 only. Okay, so now what is the n value? 334. What is n value? 34. What is s value? 5. Okay, now delete this. This one also. Here also. So n is equal to 34, s is equal to 5. While n greater than 0, n greater than 0. So nothing but 34. 34 greater than 0. It is a true or false? It is a true. So here see, a remainder is equal to n modulo 10. What is n here? 34. 34 modulo 10. If you divide 34 by 10, the last digit is the remainder. So nothing but 4. Again here, s is equal to s plus. S is equal to s plus remainder. So s is equal to 5. Very good, beta. Very good. Okay. S plus. So 5 plus. Why? Because the previous s value is 5 plus remainder. What is the remainder? 4. So 5 plus 4, which is nothing but 9. So what is the s value now? 9. So s value will become now 9. Okay. Next n. N is equal to n by 10. What is the previous n value? 34. Okay. 34 divided by 10. If you divide 34 by 10, so what is the quotient? 3. What is the quotient? 3. So n is equal to now 3. N is equal to 3 now. Okay. So now n value is 3, s value is 9.